video and have my audio, and I'll start the class effectively. So today we are looking at energy management and efficiency, and I would like us to just start off talking about how we got into what we are doing. My name is Paul Erubami. I'm the MD CEO of Max-Migold Limited. Max-Migold Limited has been providing facility management services across Nigeria and to other countries in Africa for a few years now, especially the last 5 years. We've developed some of the best facility management training, and I believe that those who have been part of our training at any time in the past would attest to the quality of the training that we provide, as well as the rapid growth and improvement in their careers of those who have taken Mastercraft FM diploma. That program is something where we would put together to be a comprehensive training that teaches you all the skills, gives you a very wide breadth and depth in facility management, and also gives you hands-on practical experience, because we have 6 projects you have to complete as part of that program. There's an exam, so it's all structured so that when you leave the program after 3 to 9 months of stay in the program, you will be that facility manager that nobody will find fault with, especially when it comes to your professional standing in the industry, okay? So I recommend for everybody who's here and to those who you know, whether practicing in FM, have been there for a while, has been working for 10, 12 years, have not had a standard professional training, or you're just coming into the industry and you wish to have a facility management training that can put you in good stead to rise very quickly. And one of the things we're going to learn today is going to be one of those topics that you don't come across every time, you don't get taught typically in many of the FM trainings you attend, especially if you do short 2 days, 3 days FM training. So today we're going to look at the whole concept of energy management from a little bit of a higher level. Okay, so many people talk about energy management and it's almost like we buy electricity, we buy diesel, we manage our generators and all that. It's a lot more than that. It's a lot more than that. The whole thinking behind energy management and energy efficiency starts from this one word: sustainability. Sustainability as facility managers. What is sustainability? The thinking around sustainability is so that we as individuals are able to think about the future while taking care of our developments for today. Sustainability looks at what's going to happen next, looks at what the next generation will have when we are all gone. And because of that, we think about how we spend the resources of the earth. Think about it this way: the earth provides all of the resources that we consume, okay, that we use for everything that we do. Whatever the earth cannot regenerate as fast as we're using it is going to be depleted or is going to run out, okay? Sustainability means that we have to think about it. Are we going to use up the earth's resources so that future generations that come will not have anything else to depend on? That's exactly where it starts from. That's where the thinking of sustainability starts from. So we're going to start by looking at, as facility managers, what are the areas of sustainability that should concern us? What are the areas of sustainability that we should actually be thinking about, okay? The first thing that comes to mind when we talk about sustainability as facility manager is energy. So I'm going to use these 8 categories of sustainability for facility managers. Pay attention to this, because this is going to affect how you take decisions, how you think, how you reason, how you buy things, your procurement. It's going to affect how you spend money. It's going to affect how you relate with your customers. It's going to affect the kind of initiatives and ideas that you can come with when having discussions at the management level. Okay. So the first thing in amongst the 8 is energy. Energy. Think about the sources of our energy. Think about how energy is consumed. Think about how energy is wasted. Think about energy performance. We'll get into that in a bit. The second area of sustainability is water. Many people think that water is infinite in supply. Water, just like energy, is not infinite in supply. Water can run out. The earth has a lot of oceans. We say the earth's surface is covered by 70% of water, but how useful is the 70% of the earth's surface covered by water? Because we know that seawater, isn't it? Drinking water, fresh water, potable water is actually a scarce commodity. For many countries, you have to drill into the ground to get fresh water. For some other countries, even if you drill, you still won't find water. Many people didn't realize what happened a few years ago when a country as developed as South Africa had issues with potable water in Cape Town. Water scarcity. It can happen anywhere. We have to think about how we use water when we talk about sustainability. And then materials and resources. The materials that we use in our buildings, the materials we use to build, the materials we bring into the buildings, and the things we use for our daily operations. How sustainable are they? How quickly can the earth replenish itself when we extract those materials from the earth? And those are the considerations we have here. And then you talk about workplace management, the work processes, what impacts do they have on the environment? If we all decide to live at one end of town and help have all the businesses at the other end of town, and we all commute every day to work, for example, what's going to be the impact on the energy consumption and the emissions, combustions that we're going to be generating or creating as part of that process? What about every day we have meetings, we call people together, and not thinking about digital solutions, alternative ways of holding those meetings? Let's look at the management processes, at the work processes that we have in place, and think about the impact. And this goes all the way to how we get things, how we use things, how we interact with nature. Then quality of service. The services that we perform, are they sustainable? Okay, what's the environmental footprint of our services? If you will always have to import everything you buy from China or from the US or from very far away place, you should think about how sustainable that is, because every flight or every ship that brings goods to you adds carbon, waste, emission in terms of fuel consumed in bringing that logistic item to you. So let's think about how we're impacting the environment. Instead of going for things from far away, let's think about things that we can get from around us, okay? What about waste? What do we do with our waste? Many of us are just so used to accumulating waste and discarding them into landfills. We think that once we have enough money to pay for waste disposal, then we are good. No, that's not good enough. Having enough money to pay for waste disposal does not mean that you should generate all the waste and just throw things away. Many people don't understand that many things that we use in our facilities today, when it ends its usefulness in one environment, becomes useful for another. Think about reuse, and then think about recycling, and then think about how to reduce to other purposes. For example, incineration to get energy from it if you need heat as a source of energy. Then think about the site impact. We build, we cut down forests, we fill up swamps, and we build concrete structures. After we have finished building, we know that we have displaced all kinds of animals, we've displaced all kinds of wildlife, and we've altered the entire terrain. And we go ahead and build concrete slabs, concrete floor, sidewalks, and then we put interlocking tiles everywhere. We create a heat island. Okay, we create an environment that is completely different from what those animals that we met, those birds, those earthworms, those little rodents, and they were used to in that environment. The impacts of our operations, even up to the sewage and the waste that we give out to the environment, pollute all the streams and ponds and rivers around us. These are things we should think about. But this is a broad scope. This is a broad view of sustainability, and I want us to have this in mind as we go straight into our number one problem, which is energy. Okay, think of it this way. Classify all of those categories as inputs, processes, and outputs. Okay, input, processes, and output. The 8 categories of sustainability. Energy we consume, water we consume, materials and resources we consume. Then think about the things we use we do as our daily work, the things we use on a daily basis, our work management, our indoor environment, our quality of services, our processes. And then when we are done, we provided spaces, people have used the spaces, we provided services, people have consumed the services. What do you have? We now have the two outputs, which are waste and site impact. Now, the whole idea of putting this in this kind of array or this kind of process flow for us to see is that, one, we are taking from the earth all of our inputs. We should be careful how we take. We should be careful not to waste. We are using them to provide comfort, convenience, productivity, well-being, health, safety, security, all kinds of things for us as part of sites and services that we provide for our businesses. Yes, but we should do them intelligently. We should not have waste in the process. And then, even if we have to have waste, we should think about how to minimize the waste, especially how the waste that we generate affects the environment around us. That should be a key consideration for how we make decisions about the things we buy, for how we make decisions about the processes we put in place, and how we interact with nature around us. So diving deep into energy now, where do we get our energy from? A lot of people don't really think about the energy mix. Where does our energy as a country come from? Our public supply will typically be, in times past where we had the hydroelectric system working well in Nigeria, we could have been a very, very high level of renewable because hydro is renewable. But now we have started to depend a lot on gas and generated electricity, thermal plants, okay? That is a fossil fuel. And then for most of us, we don't get enough from the public grid. What do? We install additional generation systems in our places, we maintain them, we fuel them. And what are we doing? We are dumping additional fossil fuel. Now, fossil fuels are particularly okay, so let's say they're easy to get, they're cheap, we can use them on a daily basis, but we extract them at a rate that is so much faster than the earth can replenish them, okay? So if we think about the crude oil reserves of the world today, let's take Nigeria, for example. How long do you think we will still have crude oil to mine out of the earth and keep, refining and using to generate electricity the way we are doing right now? We better start thinking about how to slow down, especially how we consume and the rate at which we are consuming them. But we should also be more worried about the impact of the emission on the atmosphere. We all hear of the ozone layer depletion. We all hear of all kinds of impact of combustion, all kinds of gases in the atmosphere. We should be careful how we contribute. We should be able to understand that the fossil fuel we are burning is not just giving us electricity that we use for our productivity, is also damaging our environment. Oil spills, fuel dumps leaking out, gas emissions, all kinds of carbon emissions that we should be conscious of, okay? So it's something we should be conscious of on two ends. One, we are taking it out of the earth very quickly. We should be careful of that. Secondly, as we burn them, we are releasing so much into the environment that is negative and detrimental to our environment, and we could lose the earth someday by our efforts. Now, so why are we teaching this to facility managers? Facility managers manage buildings, and buildings are responsible for about 40% of global emissions. So we are 40% responsible for the destruction of the earth. So we should think about how to do our jobs well so that we can reduce our negative impact on the environment. So this is World FM Day. And World FM Day by Global FM today and this week is all talking about the environment, facility managers and the environment. So that's why I decided to start this class of energy management and energy efficiency, talking about sustainability, so that we have the bigger picture, so that we know that the environment is a big deal. It's not because you can afford it, you should just burn as much fossil fuel as possible. No. Start thinking about having an energy mix, renewable energies, for example, energy sources, for example, combined solar. And then we have, for those of us who are lucky to have enough public supply, our public supply is actually cleaner than our own source of our own private generation. So if you can actually depend on the public supply, you'll be using probably 40–50% of renewable energy that comes from a hydro electricity dam, which is very, very sustainable. As far as rainfalls and water flows, there will always be electricity generation from a dam. Okay, and then we have solar, and then we have options to use wind, and then we have options, a few other options for renewable, even though not too practical at this point. So for FMs, I'll give you a practical tip. If you have a certain percentage of electricity availability from the national grid, try as much as possible to use a storage system. Okay, a storage system similar to what we have in battery banks that goes with inverters. Okay, a storage system will help us to store as much of that electricity when the public grid turns off, so that we can be able to use that energy. Also, be very careful, because that in itself constitutes another hazard. The batteries, the chemicals that make up those batteries on their own, how do you dispose them off when they are expired or when they run out of their useful life? Learn the recycling means. There are ways you can get these out for recycling, so that you can get other organizations to be able to put them to other kind of uses. Okay, and then you have nuclear fuels. There are so many other renewable energies that I won't have time to talk about. Some countries will be able to use thermal energy from geothermal energy from the earth, by piping, running water into the earth, under the earth to tap the changes in temperature as you dig deeper. But the purpose of energy management for us as facility managers is to improve energy performance. We don't want to necessarily reduce energy consumption, because energy consumption should be proportional to your productivity. What are we saying here? If you are managing a facility of 1,000 people, you should expect the energy consumed in that facility to be proportional to 1,000 people that are being productive, that are being comfortable, that are being given all the convenience, that have all that they need for well-being, safety, and security. Now, what we are trying to say is, as your energy consumption increases with your productivity, we expect that you should be able to track performance. For us, energy performance is what is critical. This is a metric that you must all learn. So instead of tracking how much the total kilowatt hours you consume, for example, right? Or how much the total bill is, start thinking about certain metrics you can use to take the measurement. For example, how many kilowatts per person per day, per month was consumed? How many kilowatts per liter of diesel that you generated? How many kilowatts do you get from 1,000 naira? Those kind of numbers will help you to track energy performance, because if your buildings increase activity or occupancy, there should be an expectation that your energy consumption should also increase. Don't go switching off air conditioners and lights on people because the energy bill is rising, without comparing that to the number of people that are also increasing in the facility. So be conscious of this. And this it goes a long way when we do our budget defense and stuff. A lot of us get into this drag of, you used to spend so and so amount last year, you must cut it down to this amount this year. It's a foolish argument. You can never win that argument, okay? Because there are so many factors that should be considered when considering reduction, okay? So don't begin to make people uncomfortable. Don't begin to make work unproductive because you are only dealing with absolute numbers. Start thinking of metrics so you can start counting and measuring. We can still be 100 in the facility from last year to this year. But what about customers and visitors attending the building, coming in and out? Everybody that goes to your building comes in with some level of heat, and you need to cool that up, cool that down, isn't it? So think about all of those metrics, and then start talking energy performance. That's what you want to improve. Energy performance, not necessarily energy consumption, okay? Okay, so how do we go about this? I'm going to talk about a few ideas we can all begin to deploy. All right, so start thinking about how to, oh, sorry, my slides moved faster than I wanted to. Okay, I hope you're seeing the slides today. Just wave if you're seeing the slides clearly. Slides clear to you? Last week we were seeing our faces, we didn't see the slides. All right, thank you very much. Okay, so think about energy, use less per unit output. If you manage a factory, start tracking how much kilowatts, how much watts in energy quantity goes into every product unit, that goes into everybody that comes into your facility, that goes into every activity you run. Your goal is to achieve the same results, but less energy applied. Use more energy derived from renewable sources. So start thinking about how to reduce your fossil fuel dependence. That is a very key requirement now for facility managers. Start thinking about how to reduce your fossil fuel dependence. Start thinking about alternative sources. There are things that you do in your facility that does not require your full capacity, for example, does not require you to put on your big generator. Why don't you start from that low-hanging fruit? Start finding alternative ways to power servers, to power reception areas at night, to power certain offices that are being used for out of hours work and stuff like that, so that you don't have to put on a mighty generator to run those areas. Okay, those are options you can start considering. Use energy in a more socially and environmentally responsible manner. Think about the waste, think about your emission, think about all the impacts your generators or your energy consumption causes on the neighborhood, and become more responsible. Become a responsible person in terms of how you take care of not just the environment, but the people who live in the environment. Every time you allow your oil and your diesel and whatever it is and your smoke to emit into the environment freely, because it doesn't disturb you, mind you, it's not only affecting the environment, but also affecting human lives around you. We must all be conscious of this. Understand your energy consumption and purchasing. How many of us know what a kilowatt hour actually means? When you see your bill at the end of the month and it says it's 40,000 naira or 50,000 naira, and they tell you, oh, you have consumed 1,300 kilowatt hours this month, can you relate that bill to running an AC for 1 hour? Do you know what your AC actually costs you per hour? Do you know what your refrigerator actually costs you per hour? Do you know what your lights actually cost you per hour? Can you relate that to get a sense of, if I decide to put off that particular meeting room where there's nobody right now for 4 hours, how much have I saved? Can you come to terms with that? Can you understand exactly? I'm going to talk about a little bit further about how energy billing is done for different classes of customers when I look at macro energy saving solutions. Okay, improve the efficiency of your core building system. And walls that are not well insulated, you are actually spending money in electricity that is being wasted. If you put an air conditioner on, what the AC tries to do is to maintain a certain temperature that you have set on the thermostat, right? Now, if you set an AC to go to 23 degrees inside as what you should have for your comfort, and outside the temperature is 32, 35, 38 degrees, right? What is going to happen when you have cheap, poorly insulated building fabric, or where you have defects that you have not fixed and there are little holes here and there where the air goes out, so that you can even go outside and touch your wall or your window and feel the coolness that you are trying to do inside? You are cooling the garden, and it's a huge cost. So your building fabric will consume a lot of your electricity through your air conditioning system, and you may not know how this works. You may think that if building A put on its AC from morning till evening, and building B put on its AC from morning till evening, what's the difference? There's a huge difference. If building A is well insulated, the building fabric is well properly built and maintained, that air conditioning system will be tripping up for most of the time. The compressors will go off when they hit their saturation point that is set on the thermostat, right? And once they hit that saturation point, the inside remains cold for a long time. There will be no need for the air conditioner to pick up again. At that point, you are saving a lot of money, electricity, that the compressor is not wasting at that time. But if you have another building that ACs are on and we are working in the same building for the same period of time, and that building has a very bad building fabric construction and maintenance, what you're going to have is that the ACs will struggle all day. The ACs compressor will not have any time to trip up. They will just work throughout, and that could cost you 3 to 4 times the energy consumed by the other building that is properly insulated, where all the linings are well done, where the windows are double glazed, for example, or high quality glass, and where the walls are properly done. Okay, and then your facilities energy use needs to be optimized. It doesn't help you where you have things switched on that nobody is using. Lights and ACs are on in several areas of your facility. Nobody's using them. Optimize it. Don't make people uncomfortable, but do not allow waste in your facility. Think about involving occupants in facility energy use, energy efficiency initiatives, because you can't do it alone. You cannot be in every space in the building that you manage. You cannot see everything that your building users are going to see. So if you involve them in it, it is more likely that they will support you. They will take simple actions like switching off things when they don't need it. They will not wait for you to create systems to solve that for yourself. They will see themselves as part of a team, people who are fighting for a particular cause, people who want to achieve something with you. You must sell that to them and get them involved. Reduce and cooling load through improvements made to building envelope. Spoke extensively about that. Identify energy used by all core systems. You must know exactly how much energy is being used by every of your systems. And energy you must pay. And then there are some maintenance you must do on the equipment you have in your facility, just so that your energy consumption will go down. You think that noise that's coming out of your elevator, or that sound, or that vibration you are feeling in your air conditioning, you think they are just vibration is not a big deal. It's a big deal because every energy used in creating those noise and creating those vibrations costs you on your bill. Because it's not from nowhere that those errors, those faults are creating themselves. The machines, the engines, the motors, they will find their way to keep working under pressure, using more energy to produce the same or even less quality of resources or efforts or outputs that you designed them for. So think about this as you consider your energy efficiency. Now, management does not normally look at energy cost reduction or energy efficiency as a significant aspect of the business, because the core business will consume a lot more than the support business. We are part of the support business, and we know that the support function core to it are facility management and HR. Okay, for facility management, every naira you save from your energy that you've cut out of waste, where does it go to? It goes directly to profits of the organization. So if you are able to show that because of your intelligence, your improved operations, your better working with people, you saved an X amount of money, you should be able to find that money in the company's profit and loss account. This year I saved 20 million. This year I can say that if the company made 200 million, part of that 200 million came from me. 20 million came from my efforts because I reduced my energy waste and energy consumption. So where do you start from? You need to focus on this very key knowledge. You need to conduct energy audit. Every facility manager, we do energy audit as a service. So if you come to Max-Migold and invite us to come and do your energy audit, we have some projects on hand right now. We will come in and do a thorough energy audit, give you, a clear analysis of where your energy is going and how much you are wasting, how much is being productive for you. But as an FM, you should be able to do basic energy auditing. Okay, look at your lighting. How efficient or effective are those lights? Are they the old what do you call them, fluorescent lights, or incandescent lights that 60 to 100 watts of energy consumed, we're producing 3,000 lumens or even 300 lumens of visibility or light intensity, similar to what a 5 or 10 watts LED or even mercury energy savers nowadays can provide. So let's be conscious. Let's not just think about our facility as it doesn't matter, the building is being set up. You should be able to look at total load of lighting, total impact of your building envelope, total impact of your air conditioning, even all the other office equipment. You know what their ratings are, right? If you're able to just make an outline of the electricity wattage, the rating of everything that consumes electricity in your facility, you've started, you've become competent or proficient in energy auditing. So you can say, if all my equipment and all my systems are running now, this is what my load should be. But of course, that's not the reality. The reality is that as the equipment starts getting older, start having defects, their actual consumption tend to rise beyond and above what was stated in their nameplates. Okay, so be conscious of those. And that also applies to air conditioning, that even if air conditioning is brand new, if your building envelope is not effective, if your building is having all kinds of leaks and all kinds of defects on it, your brand new air conditioning will immediately begin to run higher consumption of electricity and energy compared to what the manufacturer expects it to run. So do your energy audit just by taking an inventory of all your assets. Of course, if you are a facility manager that already have an asset register, that becomes your base. You simply just identify all the assets that consumes electricity, and then you go and find out how many kilowatts or wattage rating they are all designed for, and you indicate that, okay? And then you begin to put in plans in place to ensure that the ones that are defective. Now, but this is a point. You may think that you are saving money by allowing an AC that is already faulty to work for another 1 year. You need to actually know the difference between what the electricity is consuming now is compared to what it was designed for at normal times or when it is new. Now, if you know how much you buy electricity, you may find out that between now and next year, you could have spent as much as you need to buy a brand new AC. I'm not even talking about fixing it now. But many FMs don't think about maintenance with this mindset. They say it is still working, let us manage it, right? That is penny wise, pound foolish, because at the end of the day, you will end up spending money on energy to power a defective equipment. So think about it very carefully. And then, as you manage your facility, do not depend on your energy bill or your meter. Many of us have this one meter that meters the whole building or meters every floor. Now, those meters can give you a sense of trend, aggregate trend of how electricity is being consumed. So you can match that against occupancy and visitors to the building and footfalls from retail malls and all that. But if you are really going to drill down to energy efficiency to find out what equipment is defective, that's costing you more in energy consumption, what area of the building is being used by one or very few people, and yet they are leaving a lot of devices on in that area, you will need to manage your metering to the sub and sub levels. What am I saying? Beyond the metering you have at the main entrance, the mains, transformer, your main panels and all that, you now need to have metering at the circuit level. The circuit level is where you have a distribution board. So if you have a floor in an office block, for example, and you have a distribution board, every distribution board will have multiple fuses and switches in them. The circuits that run in that floor or that area or that flat will normally run through that circuits, run through that distribution board. You can actually have a metering device that can meter each of the circuits. So you can tell that a particular air conditioner that is fixed to a 20 amps fuse on that DB is the one giving you a problem. So you can decide to fix it. In Max-Migold, we represent the British Energy Savings Technology in the UK, and we have the Eniscope system. The Eniscope system is a circuit level micro monitoring system. It's an energy management system that you can use to monitor on an ongoing basis every circuit that runs in your facility. So you can actually pinpoint on a daily basis what was left on overnight, for example. You can tell which equipment is going to go bad soon, because once the energy profile begins to increase, you can already see that that particular equipment is going to go bad. It's already showing signs of defect. So there are a lot of things you can do with that level of monitoring, and you can track that on an ongoing basis. If your AC begins to consume a lot more, for example, begin to use up a lot more energy, you may need to look at your building fabric. But of course, if you don't have the data that tells you which area, which particular equipment, which system is changing in its energy use, you may not be able to help yourself, okay? So sub-metering, energy management systems are very critical to your work as facility managers as far as the energy management is concerned. All right, so the energy audit I talked about is just a way to divide each of your building energy use into units, and then measure what each one consumes. And that starts basically with your asset register. You take your asset register, you itemize all the things that consume electricity, you take out what the manufacturer says they should be consuming. You should be all familiar with it. Many agents manage a lot of equipment. We just go ahead and buy things without even thinking about the energy consumption of the items. Many of us even do analysis between two products. Should we buy this air conditioning unit or that air conditioning unit? Okay? You're making that decision, and you're not asking yourself, what is the energy consumption of each of them? Oh, this one is 180,000. The next one is 130,000. Why should I waste 50,000? Buy the one of 130,000. Don't forget that you're going to use this equipment for 5, 6, 8 years. Have you checked that the one of 180,000 today is going to consume less than 50% of the energy required for the other one you're buying for 130? So many times you make a recommendation to management, without this recommendation looking intelligent, management may be saying no to your proposals or to your business cases without you understanding why they are denying you certain projects or certain approvals, okay? Your analysis has to be thorough. You must understand the implications. Because if you use only the amount to buy to do your assessment, you've lost control of more than 60 to 70% of the real cost. Because for every asset you buy, the operating cost is usually higher than the procurement cost. And that's what many people don't realize. So you can save on 30% today and lose on 70% over the life cycle of that asset, okay? So the energy audit seeks to document things that are sometimes ignored in the organization, such as energy being used on site per year, which facilities or buildings use most energy, and all the opportunities you have for savings. But in fact, no cost operational and maintenance adjustments that will save energy. A lot of things you can do, just changing. Take, for example, one person stays back to work for 3 hours, and you have to leave generator running for that one person. That is a huge cost to the organization. If the organization realizes that and says, you know what, let this person work in a room that we have an inverter connected to one small system for this person to work, that would be a huge savings. And you didn't spend a dime. You don't have to spend a dime to make that kind of change. Short-term, low-cost energy efficiency retrofit, a recommendation. So you could do some simple retrofit. For example, many of you have fluorescent tubes, and every time it goes blunt, you go ahead to buy another fluorescent tube to replace it, isn't it? Now, if you are trying to move away from high energy consuming lights to low energy consuming lighting system, what do? You just simply start using your operations funds. Instead of buying the same fluorescent tubes and fluorescent chokes and fluorescent starters to replace those ones, you start changing, areas in sections. So you don't even have to create a request for huge funds, so that you can go and do energy efficiency and change out all the lights. Many people just start out to say, oh, we want to change out all the lights. It's going to cost us 4 million. Management say, no, we don't have 4 million for you, right? But forget that you spend some 400,000-500,000 in a year replacing tubes and bulbs that are dying left, right, and center. Just switch, okay, and create a plan that will even be less expensive in the long run, okay? And then start planning for capital investment. So when you're doing capital investment, be conscious of management's requirement for justification. Many people think that we can sell the sentiment of sustainability to management. Management is all out there for profit, let's face it. For most companies, it's about the bottom line, okay? So when you are selling sustainability, make sure sustainability is also profitable. Your analysis will be short and will not be accepted if you're only thinking about using the sentiment of sustainability as saving the earth. No, you save the earth, you save your company. You don't want to run the company out of business as well, okay? And then think about the building codes violations that exist in your facility. As you are doing these energy audits, as you're looking at your building fabric and looking at your building equipment and assets, there are so many things that have failed code requirements. Many of you have electrical systems. I mean, if I go to some of your panel rooms, you will see cables flying left, right, and center. You see DBs that are not labeled. You will see light cables, just tied up and hung up somewhere where an equipment was removed and somebody was supposed to tidy up that cable. It was not done. You will see all kinds of things. You see systems that are not earthed, properly earthed, or earthing that were done in the 70s and 80s that have not been revisited. You see portable appliance testing that has not been done. You pick all of these as part of this audit because it will help you fix the electrical defects that are going to cause more energy loss, more danger, and potential fires in the future, okay? All right, so let's quickly look at some skills you can deploy for saving energy. Let's look at load shedding. Load shedding as a technique for energy saving. Load shedding is when you move a particular activity that consumes electrical energy and you move it completely not to be done. Okay, so you cancel it. Take for example, if you have people going out for break, you say the office is closed from 12 o'clock to 1 o'clock, right? If the office is closed from 12 o'clock to 1 o'clock, but we leave all the air conditioning running, we leave all the lights running, we leave all the systems operating. If you actually shut down for that period that the company does not expect productivity, because in essence, when it's break time, we don't expect productivity at that time. We expect you to take that time off, isn't it? Okay, so if you shut things down during that period, you're actually doing load shedding. You can do load shedding at different times of the day for different activities. You can stop certain operations deliberately just to make sure that your load consumption comes down. That's load shedding. You could also do load shifting. Load shifting means that you will still do this particular activity, but you will move it from a certain peak time to another time that is off peak. Now, for most of you that have MD meters, transformers in your facility, and you are point load consumers for the public utilities, the way they bill you for your electricity bill is quite different. While the rest of us who are just on the R1, R2, C1, C2, or probably lower tariff, so what they basically do is they'll calculate every kilowatt that you consume per time. So that's why you call kilowatt per hour. So they take kilowatt consumed between 9 and 10. If it is 100 kilowatts between 9 and 10, that is 100 times 1 hour. That's 100 kilowatt hour. That's how they calculate your bill. So if between 12 and 1, you consumed 400 kilowatts during that period between 12 and 1, then that period, it will now become 400 times 1, which is 400 kilowatt hours. Added to the first 100 kilowatt hours, that's 500 kilowatt hours for 2 hours, right? Now, but if you are on a point load or maximum demand metering, most of those meters that you cannot read, some of those meters are the only ones that come and tell you what the meter is saying, okay? Those kind of billing, they will normally measure your load consumption based on your peak. Many people don't even know this. It's your peak consumption that you are billed for the entire 12-hour day or 8-hour day that they bill you for. So basically, if you can drop your peak load by shifting things that do not need to be working at that time, why do you want to be pumping water at the same time everybody in the office or computers are on, or ACs are on? Why don't you pump water in the water pumps in the evening, boreholes in the evening and morning to reduce your peak? Why do you want your sewage plant to run automatically? Oh, we all want technology. We've deployed automatic systems. And so once the thing drops to a certain level, it peaks again. Once you know what your capacity is, once you know what your consumption pattern or your loading pattern is for any of these systems. You can use actuators. You can still use technology. You can set them up to start pumping in the evening between 5 and 7 and between 5 and 7 in the morning. You can use timers to run those systems, and they will still trip up. They don't have to come on when the entire office is on full load. That's what we're saying about load shifting. You don't need to do laundry, for example, you're in a hotel. You don't need to do the laundry during the day. You know, you can, when the guests are sleeping and the load consumption has come down, you do laundry. So these are ways to manage your peak so that your billing can be, you know, reasonable, and you would have saved a lot for your organization. Now, so I've talked about a few of the macro measures you can take, okay? Many of us have learned a little bit about the macro measures, you know, make sure your building fabric is okay, take care of your power factor correction. Those are macro measures. Make sure your electrical defects and code compliance are implemented, so you don't have electrical defects causing heat discharges, heating DBs and circuit boards that you lose electricity in. You also take care of your equipment. You maintain your large equipment and systems to ensure that they are all, you know, working comfortably and reduced in terms of energy consumption and waste. And then you think about right sizing of your cabling, for example. Instead of using a smaller armored cable because it's cheaper, think about the capacity of load that you're going to run through that armored cable and buy the appropriate size of armored cable. Expensive at the beginning, but those kind of macro decisions will bail you out a long run. For example, installation of your roof and ceiling, choosing the right materials for your windows and doors, just to ensure that your building is well insulated. But many of us lose out completely in the micro consumers. Poor connections. I've seen too many of your electrical technicians using their teeth to peel cables and twist cables together, use black tapes on them, and their job is done. Every poor connection, every dirty connection, you lose electricity. You lose energy. Where you should have put a 2.5 mm cable, a 4 mm cable, you put a 1.5 mm cable because it's cheaper and because it works. See, somebody once said, you know, this thing has been installed there like that for almost 5 years and it doesn't give problem. You know, why is it now? Mind you, if you undersize the cable, you're making it to work harder, and it takes a lot more energy to run that system. If you've been getting away with it, that there's not been fires and there's not been anything untoward dangers in the past, is because we run a system where we don't have a continuous loading of that system. If not for public supply being epileptic in Nigeria, you will see mass fires in many neighborhoods. People will have neighborhoods burned down because of the terrible cabling that we do around. You will see welders throwing cable to the armored, to the high tension or to the low tension cable just to connect to their welding machine. That is beside a pool of water. So a lot of things we do. Many of us, we see, we want to install an AC, you cut the cable, you don't use cable connectors, you don't use cable lugs, you just connect them, just tie things up until you're fine, okay? So if we have survived fires, if we have survived other hazards that could have happened, shocks and the rest, let's know that we are surviving those ones by the grace of God, but we're not surviving the loss of money that our higher energy cost is causing as we do those things, okay? And the low power factor, many of us don't even consider any analysis on power factor. And that's why I would recommend the energy scope system to you. If you have a very high energy bill, if you have a very high diesel cost in the month, in fact, if your diesel costs in a typical month is and your electricity bill, typical month combined, is running close to 2 million, 2.5 million a month in your organization, come to Max-Migold. We will deploy our energy management system for you for free. Absolutely free. You won't even have to pay for it. We will cut down your energy consumption, and then we'll just take a share of the actual savings. If we know that you were spending 2.5 million a month before, and we install all our systems and all our analytics and all our monitoring, and it cuts down to 2 million a month, what will you do with the 500,000? We're not saying give us everything. We're saying just put it with us 50-50 and we'll be fine, right? We save you money. We give ourselves some credit and some rewards for our intelligence and for the good work that we have done for you. So take that up. Then think about your installation, cables installation. When we keep saying buy Nigeria cable, many people take it for granted. They go and buy cables that are coming from China. The biggest challenge we have with those cables are their installation. Buy cables that are properly insulated, because every time you have leaking insulation, you are not only exposing yourself to shock and other fire hazards, you are also losing energy. So my point here in talking about this is, you lose money every day when you are saying, thank God there is no fire. So be conscious, be careful how you run these facilities, because you're supposed to be a steward, you're supposed to be responsible. Let's just be conscious of how we do them. All right, so I've talked about sub-metering and monitoring system. I've talked about this extensively. If you need more information about this, talk to Max-Migold. We're here to deploy all our energy solutions to all clients across Nigeria and West Africa. That's where I'm going to stop the presentation for today. I'm just going to quickly say that we're going to ask I'm going to open for you to be able to ask questions. The way the question and answer is going to go is this. I will allow you to raise your hand. So right now, while you are still listening to me, I believe you must have written your question down. Raise your hand on Zoom, okay? When you raise your hand on Zoom, I'm going to unmute you one by one to ask your question. That's what I want. And I'd like to say, everyone interested in the facility management diploma program should please go ahead and register. It's maxmigold.com/FMMC. That is where we have a comprehensive package in facility management. It does not just teach you theory. It teaches you experience. You come out of that program in 3 months and you'll be talking like a sage in facility management. Many people have been trying to join this program for the last few years, and I see that they keep saying, oh, I don't have money, I don't have money. People who did not have money 3 years ago still don't have money now. And that's a shame, because in that 3 years, you could have been twice richer than you were 3 years ago if you had made the effort to improve on yourself. Besides, this period of slowing down economy is the time for you to cool yourself down and learn new skills. Become qualified, show certifications and credentials that employers, when the economy begins to boom, will promote you for or give you new opportunities for. That's what I'll tell you about the program. We have other short programs, but the Mastercraft Diploma is what I recommend for everybody. I want everybody to be part of the program. It starts on the 26th of May, and it's going to be 100% virtual. So there's nothing like, I don't have time to attend 3 classes a week and do assignments and do exam. No. It's going to be 100% virtual. It's only the instructors and administrators that will come to the training center. Every student will be 100% online in the program when we start on the 26th. So if you want to join, please do your registration, and then you could be part of the program. If you have money issues, we have other provisions we have done on our website. Just read through them, and you see the opportunities that we have in the system. So let me see how many hands are up. One more thing, please. If you want the slides for this training, I will give it to only a few who can send a message that clearly outlines 3 descriptive learning or lessons learned from this class. If you can describe clearly 3 lessons you have learned from this class, you will get the slide, okay? So nobody should be sending a request for the slide without saying that they have actually learned 3 solid lessons from the class, please. Send your lessons learned to 0802 2020 122. I'll say that again. 080 220 20122. That's the Max-Migold official line. And you'll get it. Please send it within 24 hours so that we do not have to start responding to people sending messages on Tuesday and Monday next week. Within 24 hours, we send it all at once on Friday morning or Thursday night. That's how we send the materials out, okay? For those who actually show the value of what they have learned by being able to itemize clearly 3 distinct lessons that they're going to apply in their work. They will get the material. It's a case of the talent, right? You use it well, you get more. Okay. All right. So I'm just going to look at the class now. All right. Okay, so whose hand is up? I'm seeing Moses, Steve, Tunde, Damilola. Okay, so let me go straight to the first person. So I'm going to unmute you now, Moses. Go ahead and ask your question. Good evening.
Thank you for this opportunity for us to learn more about facility management. And I pray that God will reward all your efforts.
Thank you.
Yes. Okay. I can see that from all your presentation on energy, mostly talks about an organization that is saving costs for your organization. You didn't really talk much on when you are operating a commercial complexes that involve other organization in a complex. My question is, how do you do your audit, your energy audit in such a situation? And then another problem I have is that, the complex that I manage, it's an open plan complex. So when customer come, they tell us, when a client come, they tell us the square meter they want. So it's not a fix. It's not how do I put it? It's not an already made office. It's something that we partition for each client. So now, and we are thinking of every organization having their own meter, because we only have one meter in the building. So how did that have been an headache for us for over how many years now, because we are unable to do that. So how do we go about that?
Okay, thank you very much. That's a very good question, Moses. So that's one of the big challenges FMs have. If you have a multi-tenanted environment, you must create it right from design. You must have consideration for operational issues like this. How do you have a multi-tenanted environment where each person cannot be built separately? If you have a situation that you are dealing with right now, then you have to make sure that each tenant sign up to energy efficiency audits and controls. Because what you're basically doing is you're using an arbitrary square foot ratio, for example, to split energy bills, which is actually criminal, because some people are being ripped off in that kind of environment, okay? And some people will not have the mindset of energy efficiency because they believe that whatever they spend doesn't matter. I mean, think about how Nigerians use electricity these days. Because the public supply brings in estimated bills, what do you think they do? They leave lights and air conditioning on, they travel. Because whether they use it or they don't use it, the bill will still come the same amount, isn't it? That kind of recklessness, that kind of evil intentions can easily crop up in the minds of people that do not have personal accountability for their own consumption. Okay, no matter what you do in such an environment, you will not get a good result out of it. So the best bet is from design, ensure that the electrical wiring is separated. So if you run an environment like that, even if it's built as open plan, so that people can pick the kind of square meters they will take when they come in, you must arrange it in a modular system where if it's 50 square meter modules or 100 square meter modules, it's such that when people come, they pick multiples of those modules, and you can install their DBs, and then the meters can be, designed, to be installed with the DB for that module. So if somebody takes, I want 1,000 square meters, no wahala. That 1,000 square meters is automatically 10 such modular spaces combined together for you, and you can put together electrical wiring so that every module is self-contained. You have electrical wiring done separated for that unit. It's a big problem for operations, and most of the time you tell me to come and manage facilities that don't have this consideration when they were building it. I don't even touch it with a 10-yard pole. But for you, I would just say, do the best you can. Do the best you can, but you may have to actually rewire that facility if you want to separate the consumption, because if you don't rewire it or reorganize the wiring, you cannot put meters for individuals. And until the person paying the bill becomes accountable, he will not listen to any energy efficiency you are talking about. Okay, so if you have separated it and Mr. A sees his bill is 40,000 and Mr. B is only 5,000, he will want to find out what Mr. B is doing to bring his bill down to 5,000. He will listen to energy efficiency. But if at the end of the month, whatever you spend, all of us pay 50,000, you're wasting your time. Energy efficiency will not work in that kind of environment. All right, so I'm going to take Tunde Akonde now. I'm going to unmute you.
Oh, thank you, Mr. Erubami. I'm really appreciative of this presentation. My question is more of a scenario that we're facing at the moment. We actually had to write to NEC to resolve an issue we're having with the Ikeja Electric on one of our properties. Now, the area I want you to explain is actually, you said something. We have an MD meter, is a multi-tenanted
environment
office facility. We have an MD meter and we have our own transformer. What we have observed is that before the property was commissioned, we had a commercial meter, which was the normal billing system. So what we discovered is that we're paying a bill on that, and the bill was you can easily calculate it by number of hours and all.
Consumed.
The moment we switched over to the transformer, the bill just went up about 5,000%, and we were wondering what happened. Anyway, they said no, there's a way they calculate. They came back, they did some funny calculation, and they were able to justify, of course, the bill. The bill shoot up to about 800,000 from maybe 250. So we were on that, and we're trying to manage it. Now we're paying #1 million or more, and we still run close to that on generator, on diesel. So recently, we've been giving some bills that were really not, consistent. And we looked at, we have in our facility, we have check meters, we have a prepaid meters metering system for every floor, so we could track what was going on. So, but what we now found out was that we were suspecting that there's an issue of overbilling, because when we looked at the billings on our prepaid meter, the check meter we have for each floor, and put all that together and compared to the metering from the MDF meter that we have, we noticed some discrepancies on that. And so, and again, over time, about 3 years now, this has been ongoing. But one thing that we were very certain of, that we knew that in December, normally our consumption go down from the second to the third week of December. Of the companies will shut down. But what we observed in 2 December that has gone by is that our bills even go much higher in December. So I want to say, so something must be wrong.
Let me attempt a question.
Okay.
Sorry. Yeah, you will let me make it brief so others can also ask their question.
I want to summarize now. So the conclusion now that we are at the Ikeja Forum trying to resolve the issue. But what you said that was very pronounced is that you said that they picked the peak reading. I'm trying to reconcile that for consumption, the people that are on the kind of meter that we run, the energy company will pick the peak reading and use it as a multiplier to generate the bill. I'm trying to find out, would that be what is responsible for the high billing we are getting, and how would that relate to the bills like in December, when 2 weeks of the month actually where the energy consumption is quite low because the occupancy dropped during that period? Thank you.
Okay, so I can just tell you that you have answered your question. Okay, so when you are not on MD billing, you have the the kind of billing you understand. How many kilowatts you consume is what you're billed for. But as soon as you get into MD billing by acquiring your own transformer and changing your account and all of that, you are billed for a flat peak, and that is deliberate. The distribution company, this is how they work, right? For heavy users, for point load consumers like you, okay, what they try to do is that they increase their distribution capacity to accommodate heavy users. Take, for example, you have 3 or 4 heavy users like you, and all of you decide to get your alternative energy source the next day. What's going to happen to the additional transmission and distribution equipment they have upgraded to serve big users like you? So MD billing is deliberate. It's like you paying an infrastructure charge to the disco to accommodate your heavy consumption. So you are safer off sharing transformers and being on the normal commercial tariff, because that's the only one that you can fully control. Now, if you want to test this hypothesis in your facility, try to meter your kilowatt hour consumption, identify what your peak hour range is. Let's assume your peak hour is between 1 o'clock and 3 o'clock, and then deliberately shut things down between 1 and 3 every day for 1 month and see how it will affect your bill. Your bill will drop drastically, I assure you of that. Okay? All right, I'm going to give the mic to Chika now. Chika, please, I'm going to unmute you to ask your question.
Okay, thank you very much for a wonderful presentation. May God bless you as well. My concern and my interest is the aspect you spoke about, the air conditioning, the AC. You said something about repairing the AC. If you repair the AC, you don't know that what you're doing, you're still adding additional costs to yourself than buying a new AC. My direct question right now is that, what is the lifespan for AC before you talk about replacing?
Okay, that's a good question. Okay, so let me try to clarify the issue of whether to repair or to replace. Whether to repair or replace doesn't really matter if you can repair it sufficiently to bring the energy consumption down to its rating. Repair is fine. Okay. Now, air conditioning useful life depends on the air conditions type and grade. I'll break that down. And by air condition type, I mean, is it a split unit, a window unit, air handling system that is part of a chiller system? You have all types of, and then you have this variable drive air conditioning now that you can have a massive compressor housing outside on the roof with several cassette units or indoor units running from that system. Now, the bigger systems, the central systems, typically will run for 25 to 30 years by design if you carry out your maintenance on them. Typically, most maintenance manuals, operations manuals from the manufacturer will tell you that. Okay, just the same way you can get 30 years, 35 years from your transformers. Those kind of lifestyle cycle you get. Now, but for your split and window systems, you can typically get between 8 and 12 years for very, very high grade ones. So if you bought the very high grade air conditioning system and you are in an environment that does not have severe environmental degradation, for example, the AC units you are using in an Ikeja or Jodu, for example, will not compare to an AC unit installed in a Lekki seaward side where you have sea salt and corrosive air around the air conditioning. The level of corrosion that you find in some areas will deteriorate your air conditioning unit faster. So you might have 3 or 4 years useful life for the same brand of AC installed in 2 different cities, depending on their climatic condition. It also depends on the use. The air conditioner you install in a meeting room that is used 2-3 times a week, and the one installed in a reception will not have the same useful life. So we do not give a rule of thumb blanket useful life prescription. We say, study one, your own experience. How long have you used this type of ACs till they start giving you trouble? It's your useful life. Study from other people's experience. Who has used this before? How long did they use it before it started giving them? Not how long did they actually use it, but how long did they use it before it started giving them problems? Those are what you're trying to find out. Because somebody can have an AC that's being fixed every month, and he has dragged it on for like that for 3 years. That does not extend the useful life. That you are struggling with it does not mean that it is useful during that life. Okay? So think about the period you actually use it historically, that it did not give you too much trouble. And also think about what the manufacturers will put in their manufacturer's manual. Many of us as facility managers don't even read manuals, and that's a shame. So try and read. The next time you're buying equipment, try and read what it says, okay? Thank you very much, sir. I'm going to unmute Damilola now. It's your turn to ask your question.
Okay, good evening, sir. Thank you very much for this training. It's really helpful, and God bless you in Jesus' name. So my question is, okay, I'm in an organization whereby they don't actually look at the facilities as a big deal. Their focus is on contracts and getting more money. Do you understand? And when the money comes, they just feel like they can maintain every other thing. They don't look at how to cut costs and all of that. So when it comes to maintaining the energy consumptions, especially the ACs, someone that comes in to service them. But most of the time, after the servicing, it still has a lot of ACs are in the organization that have issues, and we don't even know what the issue is. It comes in, change some things, and at the end of the day. So, and I also noticed that the money we spend on for NEPA, as in Ikeja electricity, is much every month. Is over 800,000. Do you get? And I don't know how to go about it, because now the management is not looking at how to cut costs in all these things. So how do you come in, chipping in all these things to make them understand that they have to cut costs?
Sure. Okay, so it's not really about cutting costs, okay? It's about efficiency. The equipment you are describing are not efficient. They are still breaking down despite the money you are spending on them, right? The electricity that's going into them is actually being wasted. Your bill is high. Management will not always remember to turn to you to cut costs until the economy hits. I think many businesses will see that the economy is hitting now. 2014, 2015, there was a massive recession and people started remembering where their money was entering. Now, instead of waiting as a facility manager for management to look at their bottom line and say, oh my goodness, we didn't make enough. Let's look at where to save money. You should be the one advocating for efficiency improvement now. You can start by commissioning an energy audit of your facility. Now, so for the simple walkthrough, just look at things and give you some few ideas. Max-Migold can actually provide you, experts, people from the team that can just come in and walk around with you and give you some ideas on what you can do. That's for free. But when it comes to doing a proper energy audit that will come up with an estimate of what can be saved, you will need to budget a little sum to cover the engineer's time and the equipment that will be installed for that audit. Now, when you go to management and say, we found a way to save, let's assume you've done that audit and you find that you can save 200,000 from your 800,000 every month, right? You don't go back and say, oh, we can save 200,000, so give us 2 million to implement this project to save 200,000. You say, no. You multiply that 200,000 by like 5 years. So that's like 2.4 million times 5. So when you go to management and say we can save 10 million or 8 point something million in the next 5 years, if we spend 2 million now to implement so and so efficiency measures, do the audits, install so and so efficiency equipment, they will look at you and say, oh my goodness, show me a proof that that money can be saved. Because I told you from the beginning of this lesson, every naira you save in energy consumption goes straight to profit. management will listen to you because that money is free money that they can appreciate as part of improvement of the profit or bottom line. So yes, you start the initiative. Don't wait to be told. If you are told, you usually get a cut that management will throw in that you'll not be comfortable with. Okay. All right. I'm going to take Omotayo now. Omotayo, is to be your turn to speak.
Yeah, hello, good evening.
Good evening.
Yeah, thank you so much. We really appreciate this presentation. Yeah, my question is, I manage a facility like 12 apartments.
Mhm.
We have check meters on the ground floor. We have check meters in the panel
Good.
that tell me what each apartment consumes.
It's consuming, yes. Yes.
But there's a particular apartment on the fourth floor. The man have its own check meter connected to the deep.
Yeah.
So there's a discrepancy between my own check meter and his own check meter. So at the end of every month, if my own check meter, for example, is maybe like 900 kilowatts, at the end of the month, his own check meter says might reach maybe 850 or 800. So I want to know, does it mean that it's energy loss or what? I don't.
No, okay, so there are two things. One, if the meters are not located in the same place, in the same position beside each other, right? You should trace exactly where energy loss is happening. Okay? If your meter is downstairs and its own is upstairs, somebody's probably tapping somewhere into something, you need to trace those lines to be sure that that line is free and clear. Okay? Then secondly, meters and all measuring devices need to be calibrated. Many times we just buy from the shop a measuring device or a metering device and we just go ahead and install. There are specialist laboratories for calibrating so that you can be sure that it is proper units, proper quantities that it's reading, okay? There are systems for doing that. So if you want to find out what's causing the differentiation, go that two routes. One, manually inspect the running of that line to be sure nobody is hooking up anything. Also check for what do you call it? I talked about it during the lesson, insulation leakage. There could be peeled points at some area. There could be all kinds of insulation leak that could be causing energy loss along the way. You could have faulty connection where some joints along the line are heating up and cooling down continuously. So that could lead to discrepancy because a lot of energy will be wasted that doesn't get to his meter for him to read. So you may approach it with those two approaches, okay? I'm going to take oh boy, I think I need to take just two, but I'm seeing so many hands up. Okay, let me take Esther. Esther, please, I'm going to take your question now.
Okay, good evening, Mr. Paul, and it's been a very interesting course, and I can bet you I've learned a whole lot. I've had this area of confusion, not really very much of confusion, but some kind of confusion, and you touched on it, but didn't really go deep into it. I know that we are seem to be more efficient when we're able to drive down what, in terms of maybe water usage, electricity usage, and all that. If we're able to drive it down to what each occupant of the building is consuming.
Yeah.
And what happens in a situation where you have a building with, say, 600 occupants with over 1,000 visitors and on a daily basis?
Yes.
You want to find out what each person consumes, water, the waste generated, the power consumed. Is there an empirical way of having this calculation done, or is it the regular way of doing mini, like I would say?
Yes.
Scientific way of having that calculation done.
Yeah. So thank you very much for your question. The first thing is you can't know what you have not measured. Okay. So
Okay.
the first step is install sub-level metering for virtually everything you want to measure. Okay. If you have electricity, you want to know what each person is consuming, the wiring must be done in such a way that each person's consumption can be metered separately. Okay. Anything less than that is guesswork. Okay. If you have refuse and you want to be sure of each person's impact on refuse disposal, just have a scale beside your refuse bin, main dump. Anybody that brings his refuse bag from his unit, just hangs it on the scale. Somebody issues a waste consignment note to say he has deposited so much of waste. At the end of the month, you weigh all of those and you get your impact. Even water can be metered. Every unit must have its own line that a meter is tapped at that point and spreads into that facility. All those kind of very some engineers do some things that are so rather appalling. They'll design a building with one line running from one end to the other end, and pipes entering into one apartment from multiple points. You see the water coming into the kitchen from one line, coming into the bathroom from one line, coming to the other bathroom from one line. You can't really meter what that apartment consumes because you are running lines for convenience. The best thing to do is make sure that each apartment has a point by design where the water goes in. You can spread into that apartment they use, so you can meter at that point. So everything goes back to design. Otherwise, you have to meter at every point. Say you have 3 or 4 points where water goes into an apartment. You have to set up metering for each bathroom and each toilet, each kitchen. That's really, really annoying. So that's part of the things we are trying to advocate for, so that FM's concerns can begin to go into design and construction. Don't sit back as FMs till the building is done and then they come and hand over to you and then after reading riot act to you tomorrow to come and measure this and measure that and measure this when they've not built the opportunity for such measuring. Are you going to rewire the whole building or repipe the whole building so you can measure well? That becomes a big challenge. If you send up a bill to put meters in every joint where you go into an apartment, somebody say the bill is too expensive and we can't pay for it. So that's how these efforts drop down. So let's be conscious of this as part of our design. But bottom line of your question is that you must measure before you can know. So you cannot report what you've not measured. Everything else is guesswork. Rule of thumb, estimation, all kinds of fractionating. I'm going to take Victoria's question. I'm going to unmute you, and you will have the mic. Yes. Did I just unmute Victoria or someone else? Sorry, I think I did someone else unmute. Okay, Victoria, go ahead. Are you still with us?
Yeah, I was gone.
No. I think she's there. I didn't unmute her. Victoria, you're muted now. Okay. All right. So I'm going to take someone else. I'm going to take Sulaiman. Sulaiman, you're muted now. You can speak.
Yeah. Thank you very much, Mr. Paul. Good evening, Mr. Paul.
Good evening.
Yeah, really appreciate your slide, your lecture. It's been very, very informative. Let me start with a confession. I have a sewage treatment plant. I have a water treatment plant. I run them like 24 hours. So out of what you just said now, I'm just thinking of getting back to work and see how we can run them off peak periods. So I'm just telling you, have taken something from what you said. That's number one. So thank you for that. So number two, my question is this. So I'm beginning to look at it that the bottom line of everything you are saying is once we have an improper building insulation, definitely we must have energy loss.
Exactly,
So
exactly.
The kind of structure we have is the brick cemented with window casing with glass. That's basically what we have. We are not physically seeing any energy loss. But I know that during the hot season, the demand for AC is always very, very high. You know, I get complaints like the ACs are not working, and I get there, I know the ACs are working, but I know myself that the cooling effect has been reduced. So is it because the weather out there is hot, or there's a problem of building insulation? So my question is, how do we identify and correct or fix building insulation? And lastly is, you mentioned power factor as one of the factors we should look when it comes to maybe high energy building or something like that. Can you please throw more light on that? Thank you very much, Mr. Paul.
All right, thank you so much. That's two very heavily loaded questions. Those are questions that will probably take a whole day to analyze, but let me just attempt them. First, you need to know the impact of your building fabric on your energy consumption. You need to do what we call a thermographic imaging. It's just like a camera, but what the camera reads is heat signatures. So the camera can scan from outside your building, and when your ACs are working at full blast, and see how cool and hot your walls and windows are. It will tell you exactly all the places where your cooling is being lost to the environment outside. Okay, then you can take action. For example, you can replace windows with double glazed superior material window, and that will reduce that transmission of your air conditioning load. Now, there's actually no building that can be 100% insulated from the outside environment. But when you start getting to well-insulated buildings, you are getting to a higher level, and it's proportional to your energy consumption. That's the lesson we all have to learn from this. So if you do very cheap building fabric, be ready to spend more than someone else who invested in a superior building fabric. Okay, so that's the first point I'll put there. So use thermographic imaging to scan your building from outside, and then use that to tell whether your building fabric is okay or not.
Power factor.
Okay, yeah. So power factor is what I would say is more in the engineering field. You know that when you use electricity, they come in three phases, right? And then those three phases will have to be balanced for three-phase loads. That's load balancing. And then you have the issue of the efficiency of the equipment that you are running that power through. If a system is 100%, it means that 1 kilowatt hour of electricity is producing 1 kilowatt hour of work or output. All right. The inefficiency of your system, maybe the cabling or the equipment processes or the motors, is what reduces the output compared to the input. I'll say come to class. When I teach electrical classes, I usually get electrical engineers to come and teach that, and you'll be able to ask that question and get more detailed answer, okay?
Okay, thanks.
All right, thank you. So please mute. I'm going to ask one more person to speak, and that will be the last question for the day. We've really stretched this class deep. I'm going to ask Ajibade Bashir, please. I'm giving you the mic now.
Mr. Paul.
Yes.
Yeah, I really appreciate everything you discussed tonight. Actually, mine will not be a question. It's just be like so adding to what you said. I will
Okay. Okay.
Hello?
Yes, go ahead.
Yeah. The facilities are there. They have own personal for
Okay.
seaweed. I'm just trying to like add into what you said. The way these things works out is different from the way it works in Nigeria. Okay, and in cities we have of house from construction. Okay, because
you're breaking up. Sorry, you're breaking up.
for everything you have.
The terrorist lines using.
Excuse me. Hello?
Sorry, we really can't get your words coherently. I think the network is disrupting your discussion, but it's okay. Send me a WhatsApp message with your comments. Any other question you have, drop them in the Max-Migold Facility Management Training group on Telegram. If you are not yet on that group, I'm sure you must have received some message. Just join the group on Telegram or send the chat so that I can drop you the link to join that group. We have almost 650 people in that group right now. So join the group and the discussion, intelligent discussions go on inside there. The beauty of Telegram is that once you join it, you can go back and review all the past conversations that have happened in the group. All right, so that's what we'll call it today. Thank you so much for your time. I hope you will find time to follow us on LinkedIn, follow me, connect with me on LinkedIn. Follow us and like our pages on Facebook, Google recommendation, and LinkedIn as well. So thank you. Have a nice evening, everybody. This has been an interesting time with all of you, and I believe that you've all had a good time in the class. So send me your 3 lessons learned, and then we will be able to send you the material by tomorrow evening. So I've unmuted everybody. Just say your goodbyes, and that'll be. Thank you so much.
All right, goodbye, Mr. Paul.
Bye.
Thank you very much. God
Bye.
bless.
Thank you so much, Mr. Paul.
Again.
Have a nice evening.
Thank you so much.
That number is 080.
This was quite enlightening.
220
Thank you, Mr. Paul. God bless you.
080
Bye.
220. Okay. Thank you, guys. Have a nice evening. Bye-bye.
All right, thank you, Mr.
Thank you,
Paul.
Mr. Paul.
Thank you.
Bye-bye.
Bye.